science class. The topic for today's lesson is chemicals. This topic is seen in the theme, learning about our environment. Chemicals are part of the substances found in our environment, and that is why we are learning about them today. I encourage you to pay attention because at the end of today's class, you should be able to define chemicals, classify chemicals based on their intended uses and their hazardous nature. You should also be able to identify some of the safety measures that are applied when using chemicals. Chemicals are found everywhere in our environment, and we use various chemical substances daily. Some examples of chemicals are kerosene, salt, camphor, sugar, bleach, cooking gas, plastic items, petrol, the oxygen we breathe in, carbon dioxide we breathe out, and even water. As a matter of fact, various substances in our environment are made up of chemicals. As we proceed in this lesson, you'll find out why all of these substances are described as chemicals. The food we eat also contains different chemical substances. These chemicals are required in our bodies to keep us healthy. Examples of such chemicals are carbohydrates, found in starchy food, fats and oil, proteins, minerals, and vitamins. Water is also included in the list of chemicals that are found in our food. And all of these chemicals help our bodies to function properly. So what are chemicals? A chemical is any substance that consists of matter and can be gotten from or used in a reaction. I'd like to pay attention to this definition. You know the three states of matter, right? What are they? Solid, liquid, and gaseous. So we are saying any substance that may be solid, liquid, or gaseous that is gotten from a reaction or that can be used in a reaction is a chemical. So what then is a reaction? A reaction is a process or a procedure that occurs when two or more substances combine and interact with one another. This therefore means that when a liquid substance or a solid substance or even a gaseous substance combine with another substance and interact with that substance, we say a reaction has occurred. I'd also like you to take note that when substances combine and interact with one another, sometimes they lead to the formation of a new substance. And at other times, they lead to the formation of a mixture. A mixture simply consists of the various substances that interacted and combined together. In that case, when substances react, we call them reactants. That's the substances that are combining and reacting. We call those ones reactants. And whatever products they give us, whether it's a new substance or a mixture of substances, they are called products. So for a reaction to occur, there has to be reactants and products. Do you understand what a chemical is now? I'll take that again. A chemical could be a liquid substance, solid substance, or gaseous substance that has the ability to combine with another substance to give us a product. Or a solid substance, a liquid substance, or a gaseous substance that can be formed from the combination and interaction of other substances. Don't forget this. Examples of reactions that occur daily in our environment include the reaction between a cube of sugar and a glass of water. Let's try this out. Here is a glass of water, and here is a cube of sugar. So in this experiment, we are going to drop this cube of sugar into the glass of water and we'll find out what will happen. So if you stir to help the sugar dissolve fast. As you can see from the experiment, the sugar particles are dissolving as they combine with the water. So there's a form of interaction, and the sugar particles continue to dissolve in the water. Okay, the cube of sugar has completely dissolved in the water. So we can say a reaction has occurred. The cube of sugar combined with the water, they interacted, and the sugar dissolved completely in the water. So what we have here is a mixture of sugar and water. So a sugar is a chemical, and water is also a chemical. So we have a mixture of sugar and water, an example of a reaction. Other examples of reaction that occurs in our environment include the reaction between water and metal objects. Take note that if you expose metal objects to water, after a while they begin to rust. So rust is an example of a reaction that takes place in our environment. Another example is the reaction that occurs during photosynthesis in plants. This reaction is between carbon dioxide that is found in our environment and water. In the presence of sunlight, carbon dioxide reacts with water to give us glucose, which is the starch that is found in plants. There are other types of reactions that occur daily in our environment, and all of these reactions involve chemicals. Chemicals must combine and interact for a reaction to occur. All chemicals are made up of substances called elements. They consist of substances called elements. Although we may not be able to see all of these elements with our eyes. For example, when I raised the glass of water, were you able to see the elements in water? No. Even the cube of sugar, you didn't see the elements. These elements are always there, even though we don't see them. Examples of elements that make up chemicals are elements such as carbon, hydrogen, and oxygen. These elements occur naturally in our environment. For example, the elements hydrogen and oxygen, they are found in the air we breathe. Even carbon is also found in the air we breathe. These are elements. There are different types of elements. There's a large number of elements. We cannot list them all. Now take note that a chemical may contain more than one element. A chemical may contain more than one element, and a chemical could be made up of just one element. Let's take examples of chemicals that are made up of more than one element. The first one is water. Remember we said water is a chemical? Water as a chemical is made up of two elements. These elements are hydrogen, which is represented by the symbol H, and oxygen, represented by the symbol O. So for water to be formed, the elements hydrogen and oxygen must combine and interact to give us water. So the symbol for water is H2O, that's hydrogen and oxygen. Another chemical, which is called methane, is formed from the combination of two elements, which are hydrogen and carbon. How about the carbon dioxide we exhale? It is also formed from the combination of two elements, which are carbon and oxygen. So carbon dioxide is usually represented with the symbol CO2, meaning carbon and oxygen. Both carbon and oxygen are elements. Also take note that all elements are made up of atoms. Elements are made up of atoms. What is an atom then? An atom is the smallest particle of an element. So if you have to divide an element into smaller bits or smaller pieces, the smallest particle of an element is called an atom. Some chemicals have several atoms of different elements. Let's take another example, the example of water. We say water is made up of two elements, right? What are they? Hydrogen and oxygen. Water consists of two atoms of hydrogen. So we see one hydrogen and two hydrogen atoms. So if you pick water, by the time you begin to separate the number of hydrogen in them, you discover that we have two atoms of hydrogen elements. How about oxygen in water? We have just one atom of oxygen. That is why the symbol of water is written as H2, telling you that we have two atoms of H, that is hydrogen, and one atom of oxygen, making O. So we have H2O. That's one atom of oxygen and two atoms of hydrogen. Methane also. Methane has 4 atoms of hydrogen. This is 1, this is 2, this is 3, and this is 4. Methane has 1 atom of carbon, which is just this carbon. That is why we have the symbol for methane as CH4. So 1 atom of carbon and 4 atoms of hydrogen. So chemicals have elements, and the smallest particles in these elements are called atoms. Usually, during a reaction, the reaction we described earlier, or when chemicals react, it is the atom in them, or the atoms in their elements, that interact and combine with one another. So the reaction between hydrogen and oxygen to form water, we say it is the atoms in these elements that interact and combine with one another. Having said that about chemicals, I'd like you to note also that some chemicals occur naturally. They exist naturally in our environment, while some are produced artificially in the laboratory. Artificially produced chemicals are made using naturally existing chemicals. So we use the natural chemicals that are gotten from our environment to manufacture artificial chemicals in the laboratory. Some examples of natural chemicals are, I expect you to name some. Carbon dioxide is a natural chemical found in the air around us. How about oxygen? It is also a natural chemical. Water, too, is another example of a natural chemical. Other examples include salt, natural gas, limestone, petroleum, sulfur, and natural metals. All of these are examples of naturally existing chemicals. How about examples of artificially existing chemicals? They include bleach. You know the bleach we use for washing our clothes, detergents, iodine, and methylated spirits. All of these are chemicals that are manufactured in the laboratory using naturally existing chemicals. Naturally existing chemicals are also called chemical raw materials. Why are they called so? It's because they are used for the manufacture of artificial chemicals. So when you hear of chemical raw materials, just know that you are referring to naturally existing chemicals. There are several types of chemicals in our environment. And because they are so numerous that we can't recognize them all, we have to place them in groups. This brings us to the next point of our lesson, which is the classification of chemicals. Chemicals are placed into groups based on several features. So there are different types of chemicals, and they are placed in groups. They are placed in groups according to the following. The first is based on their acidic nature. The second is based on their intended uses, as what the chemicals are made to be used for, and based on their hazardous nature. So from this point of the lesson, we're looking at the various groups of chemicals based on these 3 features. Let's take the first one, based on acidic nature. There are 2 basic chemicals that are classified based on their acidic nature. Take note. We have acids and bases. So based on acidic nature, chemicals belong to two groups, acids and bases. Let's take the first one, acids. Acids are chemicals that have a sour taste, and they can turn a blue litmus paper, take note of this, litmus paper, to red. Have you ever tasted any fruits and the taste was sour in your mouth? Have you tasted any substance that turned out to be sour in your mouth? It might just be a chemical. Let's find out. Acids occur naturally in our environment, so we find acids in natural substances such as fruits, food, and so on. Naturally occurring acids can be seen in fruits such as oranges, lemons, and lime. You know how sour those fruits can taste? It is because they contain acids. Now, if you drop the juice of these fruits on a blue litmus paper, the blue litmus paper is just a paper that is used to test for acid. So to test for acid, you have to use the blue color of the litmus paper. If you drop the juice of maybe orange, lime, or lemon on a blue litmus paper, as you can see from this diagram, or if you dip the litmus paper into the juice of any of these fruits, you will discover that that blue litmus paper will turn from being blue to red, to become red. And when it is completely soaked in the acid, it will become a red litmus paper. That is a test for acids. When a blue litmus paper changes from being blue to red, we can say that chemical is an acid. Acids also occur artificially. There are artificial acids that are manufactured in the laboratory. Examples of such artificial acids are vinegar and car batteries. The car batteries, that's batteries that are found in our vehicles, contain acid. And vinegar is a substance that we usually have in our homes. They are also made up of acids. There are other types of artificial acids in the laboratory. Even in our bodies, we have acid. An example is the digestive acid that is found in our stomach. Digestive acid, sometimes we call it digestive juice. It is an acid. What does it do? It helps to break down the food we eat. So digestive acid is a chemical. It is found in our body. Bases. These are the second group of chemicals based on acidic nature. Bases, unlike acids, are chemicals that have a bitter taste, and they can turn a red litmus paper to blue. Did you get that? They have a bitter taste, and they can turn a red litmus paper to blue. Just like we saw in the case of acid, if you dip a red litmus paper into a mixture or a liquid that you suspect to be a base, it will change from being red to blue. And at the end of the experiment, you will have a blue litmus paper. Bases, like acid, occur naturally, and they can also be manufactured artificially. General examples of bases include soap, the soap we use to take our bath, wash our clothes, detergent, etc. They are bases. Bleach, baking soda, and ash. All of these are examples of bases. Now, there are strong acids and there are also strong bases. We also have weak acids and weak bases. To find out if a chemical is a strong acid, a strong base, or a weak acid, or a weak base, we use a pH scale. So the pH scale is used to find out if a chemical is a strong acid, or a strong base, or a weak acid, or a weak base. The pH scale measures values from 0 to 14. The pH scale is just like every other scale. This is what it looks like. It has different colors that indicate the strength of an acid or a base. Chemicals that have pH values between 0 to 7 are acids. So a chemical that has a pH value of 0, 1, 2, 3, 4, 5, 6, and just before 7 are acids. The strong acids are within this area. They have pH values of 0 point whatever, 1, 2, or 3. So chemicals that have pH value of 1, 2, or 3 are strong acids. So these are examples of natural substances that contain strong acids. Chemicals that have pH values from 4, 5, 6, and just before 7 are weak acids. So the strongest acid should have a pH value of 0 to 1, while the weakest acids should have pH values from 5 to 6, down just before 7. Now let's look at bases. Chemicals that have pH values between 7 down to 14 are bases. Bases are also described as alkaline chemicals. So sometimes when we are checking for the pH values for bases, we say we are checking for the alkalinity. So we say these chemicals here are more alkaline. So we have the very weak bases within this range. So chemicals that are weak bases should have pH values of 8 to 10. And strong acids should have pH values from 14 down to 11. And these are examples of substances that are made up of different pH values of basic chemicals. Now, if you take note, water as a chemical has a pH value of 7. It is just at the middle. It is at the middle of the pH scale. So we say water is a neutral chemical. Water is not a base. It is not an acid. It is a neutral chemical. So it dissolves in anything. Now take note, the various colors shown on the pH scale tells you the different values of the chemical. So if you have a chemical that has this very deep red color, it shows you that it is a very strong acid. If you have a chemical with this deep purple color, it should tell you that the pH value should be 14 and it is a strong base. That is for the pH scale. Now, why do we need this pH scale? We need it to tell us which acid is strong and which base is strong, or which acid is weak and which base is weak. This is because strong acids and strong bases are harsh chemicals. They are harsh and they can cause harm to humans. They can cause harm to humans. They can also cause harm to other things in our environment. So from the pH scale, we know that pH values that are lesser than 6 are for acid chemicals, and numbers greater than 7 are for chemicals that are bases. Strong acids and strong chemicals are harsh. They are very harsh, and they can cause harm to humans and to our environment. They can destroy substances and even cause different types of harm. Strong acid and strong base can cause harm such as burn, as we can see in this diagram. If a strong acid gets to the skin of a human, it can cause this degree of burn. Even a strong base can cause such harm. So we should be careful how we use strong acids and strong bases. As a matter of fact, don't use them if you are not told to do so. The second basis on which chemicals are classified is based on their intended uses. So we have different groups of chemicals. We have pharmaceutical chemicals, cosmetic chemicals, agro chemicals, industrial chemicals, laboratory chemicals, and nuclear chemicals. So we are going to take this list one after the other. The first is pharmaceutical chemicals. Pharmaceutical chemicals are chemicals that are used for the manufacture of drugs and other medicinal items. The term pharmaceutical tells us that it has to do with pharmacy. And a pharmacy is a place where drugs and medicinal items are manufactured. So we use pharmaceutical chemicals in the pharmacies to manufacture drugs and other medicinal items. Pharmaceutical chemicals, just like every other chemicals, can be gotten naturally from the environment, and they can also be manufactured in the laboratory. So let's take a look at some examples of pharmaceutical chemicals. We have salicylic acid. Salicylic acid is the chemical that is used to manufacture the drug aspirin. Aspirin is a pain killer. And salicylic acid is gotten from the plant, willow plant. We also have quinine. Quinine is a pharmaceutical chemical that is used to manufacture anti-malaria drugs, drugs that are used to treat malaria. Quinine can be gotten from the plant, cinchona plant. Cinchona plant is found in our environment. It grows in the forest. This is an example of cinchona plant. Another pharmaceutical chemical is caffeine. Caffeine is gotten from coffee plants. We also have menthol. Menthol is a pharmaceutical chemical that is gotten from mint leaves. Menthol is used to manufacture balm and other methylated ointments. So it's gotten from mint leaf. We have morphine, an example of pharmaceutical chemical. Morphine is a strong painkiller. It is used to manufacture strong painkillers. And morphine can be gotten from licorice plants. These are the roots of licorice plants. The last example of pharmaceutical chemical is acetaminophen. Acetaminophen is a chemical that is used to manufacture paracetamol. Now let's look at cosmetic chemicals. Cosmetic chemicals are chemicals that are used for the manufacture of cosmetics. You know what cosmetics are, right? Well, cosmetics are substances that are used to improve our looks. We use these substances to improve our beauty. We use them to also improve the way our bodies smell. So examples of cosmetic chemicals are substances such as soaps, perfume, cream, powder, and oil. All of these chemicals are manufactured using cosmetic chemicals. Examples of cosmetic chemicals are ethanol, caustic soda, formaldehyde, triclosan, acetone, glycerin, castor oil, coconut oil, and olive oil. All of these are used to manufacture beauty items. For example, soaps. Soaps are made with chemicals such as caustic soda, oil, and so on. So for the manufacture of soap, you must use caustic soda and different types of oil. How about body creams? Body creams are made using chemicals such as oil, water, glycerin, fragrance, and alcohol. The third group of chemicals based on their uses are agrochemicals. Agrochemicals. From this term, agrochemicals, we should know that these chemicals are chemicals that are used in the agricultural industries to improve the quality and the quantity of agricultural products. So agrochemicals are chemicals used in agricultural industries. They are used in our farms and they are used in the various storage facilities. They are used to improve two things: the quality and the quantity of agricultural products. Agrochemicals include various lists of chemicals. They include fertilizers, pesticides, and hormones. Fertilizers are chemicals that are used to improve the growth of crops. We use fertilizers to improve the growth of our crops in the farm. Fertilizers provide nutrients to the soil and they help crops to grow properly. Examples of fertilizers are NPK. This is a name for a group of fertilizers. Then we have calcium hydroxide. These images on the screen are various types of fertilizers. The second type of agrochemicals are pesticides. Pesticides are chemicals that are used to kill organisms that disturb the growth of crops and animals in the farm. So pesticides are applied in the farm to kill various types of organisms that disturb the growth of crops. Pesticides include insecticides. These are used to kill insects. Herbicides. These ones are used to kill herbs, that's crops that grow, other plants that grow in the farm. Rodenticides. These are used to kill rodents that eat up our crops. We have nematicides used to kill nematodes. Nematodes are worms that disturbs the growth of our crops in the farm, and so on. These are people applying pesticides to a farm land. The last group of agrochemicals are hormones. Hormones are chemicals that are required in the bodies of plants and animals to keep them healthy. Hormones occur naturally in the bodies of plants and animals, but whenever a farmer discovers that a certain hormone is lacking, that farmer will go to the market and purchase hormones. So the farmer will have to use such hormones to help the plant or the animal to grow better. Examples of hormones are auxin, gibberellin. Auxin and gibberellin are hormones that are used for plants. And estrogen is an example of a hormone that is used for animals. Having said that about agrochemicals, let's move to the next group of chemicals based on uses. Industrial chemicals. Industrial chemicals are chemicals that are used in industries for the manufacture of various items. So we use these chemicals in different types of industries to manufacture items. They are also used to operate the engines of machines and equipment. So we use industrial chemicals in the engines of machines and equipment. We use them to operate those equipments and machines. Examples of chemicals used in the industry and the things they are used to produce are as follows. We have polycarbonates, polystyrene, and polyvinyl chloride chemicals. All of these group of chemicals are used to manufacture plastic items. So when we see plastic items, you should know that any of these chemicals must have been used to produce them. Used to manufacture plastic water bottles, plastic chairs, plastic tables, and so on. Silica. Silica is an example of industrial chemicals that is gotten from sand, the sand that is found in our environment. Silica is used for the manufacture of glass items, such as our glass cups, glass windows, glass doors, and so on. Wax, naphtha, and turpentine dye. These chemicals are used for the manufacture of shoe polish. They use them to manufacture shoe polish that is used to clean and polish our shoes. Wax, as a chemical, is also used to manufacture candles and crayons. Polyester and nylon. These are synthetic fabric that are manufactured in the lab from chemicals. Polyester and nylon are used for the manufacture of clothing items. So we use polyester and nylon to make clothes. This is nylon and this is polyester fabric. They are made in the laboratory using chemicals. We also have steel, tin, bronze, copper, and gold. All of these are metal chemicals. Metal chemicals are used for the manufacture of metal items such as spoons, rods, and jewelries, or any other metal item you can think of. They are manufactured using metal chemicals. Let's move to the next group of chemicals based on uses. We have laboratory chemicals. Laboratory chemicals are chemicals that are used to carry out experiments and researches in the laboratory. What is a laboratory? A laboratory is a place where researches and experiments are done. just like the laboratories we have in schools and in several other places. In the laboratory, scientists or people go there to carry out researches and experiments, and they do this using laboratory chemicals. Examples of laboratory chemicals are methanol, sodium hydroxide. Sodium hydroxide is also called lye. We call it lye. Sodium hypochlorite, which is commonly called bleach, is also used in the laboratory. Ammonia and iodine. All of these are used in the laboratory to carry out different experiments and researches. The last group of chemicals based on their uses are nuclear chemicals. Nuclear chemicals are chemicals that are used to carry out radioactive processes. Radioactive processes. What are radioactive processes? These are activities that involve the release of energy rays by the splitting apart of the atoms of some particular elements. Let me explain what this means. This means that for a particular kind of element, their atoms split apart to produce energy rays. These energy rays could be in form of light or in form of explosions. It is not for every chemical, take note. Say there are a particular group of chemicals whose atoms split apart to produce energy rays. So, activities that involves the use of chemicals whose atoms split apart to produce energy rays are radioactive activities. Nuclear chemicals are used to manufacture explosives such as bombs. Yes, they are used to manufacture bombs. They are also used to manufacture fireworks. Fireworks. We also use them to manufacture crackers. You know those crackers we use during festive periods. We use nuclear chemicals to manufacture them. Nuclear chemicals are also used to carry out radioactive medical treatments. There are certain types of treatments that are done using nuclear chemicals. Examples of nuclear chemicals are uranium and radium. Now you know the different group of chemicals that are classified based on their uses. How many are there? 6. We can go over them again. Let's look at the next basis of classification. We say they are classified based on their hazardous nature. So based on hazardous nature, we have different group of chemicals. Now, what is a hazardous chemical? A hazardous chemical is a chemical that is harmful or a chemical that is poisonous and can cause harm. Hazardous chemicals cause harm to humans, plants, animals, and even our environment. Hazardous chemicals are to be handled properly. Hazardous chemicals are also called toxic chemicals. So we can call them hazardous or toxic chemicals. The name toxic is given because hazardous chemicals contaminate food, they contaminate water, soil, and air when they come in contact with them. That's why they are called toxic chemicals. So we get poisoned by these toxic or hazardous chemicals when we eat, drink, breathe in, or use them. When we use them, sometimes they come in contact with our skin or other parts of our bodies. And when this happens, they cause harm to us. So we should be very, very careful how we use chemicals. Usually when you see hazardous chemicals, they come with symbols such as this. This means that a particular chemical is toxic and you should be careful with it. This is also telling you that a particular chemical is hazardous and it is dangerous, therefore you should be careful with it. Chemicals are classified into 3 groups based on their hazardous or toxic nature. We have highly hazardous chemicals, moderately hazardous chemicals, and non-hazardous chemicals. Let's take them one after the other. The first is highly hazardous chemicals. As the name implies, highly hazardous chemicals are very poisonous and they are very reactive. They are very dangerous chemicals. You should be careful with them. They can cause a high degree of harm or injury when exposed to them. As a matter of fact, children are not allowed to go close to highly hazardous chemicals, so you should stay away from them. Highly hazardous chemicals can cause harm when exposed to them, even for a short period of time. They are very reactive. Examples of highly hazardous chemicals are lead and chlorine in their concentrated form. Some of the harms caused by highly hazardous chemicals are cancer. This is a disease. It can be caused by exposure to highly hazardous chemicals. Let me also mention that harm caused by some of these chemicals may not be immediate. In some cases, this harm could manifest after a period of time, say 1 year, 2, and so on. So we say cancer is an example of a disease or a form of harm that is caused by highly hazardous chemicals. We also have loss of pregnancy. Pregnant women should stay away from such chemicals because if they are not properly handled, they can cause loss of pregnancy. They can also lead to reproductive problems. People that work with these chemicals should be careful if they want to give birth to children. They should be careful how they come in contact with them. Highly hazardous chemicals can also cause birth defects. Pregnant women, the unborn children of pregnant women could also have some form of defect when the pregnant women come in contact with some of these chemicals. We have disabilities. They can cause disabilities such as blindness and so on. In extreme cases, highly hazardous chemicals could lead to death. That's why we need to be careful with such chemicals. The second group are the moderately hazardous chemicals. These are chemicals that cause harm moderately, if not properly handled. They are not as reactive as the highly hazardous chemicals, but they cause their own form of harm if they are not properly handled. Harm caused by these chemicals could result to other severe conditions if they are not well taken care of. We should also be careful with this kind of chemicals because they can result to severe conditions. They can also lead to death if they are not properly taken care of. Examples of moderately hazardous chemicals include chemicals such as sulfalate. Sulfalate is a chemical that is used to manufacture herbicides, an example of agro chemical. We also have cypermethrin. Cypermethrin is also used to manufacture pesticide, which is also an agro chemical. When using these chemicals, you should be very careful with them because they are also hazardous. The last group are the non-hazardous chemicals. Non-hazardous chemicals, as the name implies, are chemicals that do not cause harm when used in the required quantity. So these chemicals are safe when you use them in the required quantity and you use them as instructed. However, they can cause some form of harm when used inappropriately, when you use them in the wrong quantity, when you also use them in the wrong manner, they can cause some form of harm. So we should be careful with chemicals generally. So when we buy an item, we should look through the label to find out the various chemical substances that are included in that item. Examples of non-hazardous chemicals are chemicals such as amylase, baking soda, the one we use in our houses, alcohol, the one used in the laboratory to carry out experiments and researches, vinegar, and aletrin. All of these chemicals are considerably non-hazardous. Having learned that chemicals could be hazardous and they could be highly hazardous and reactive, there are certain measures we must ensure to take when dealing with chemicals. These measures have been put together and they are called safety measures when using chemicals or safety measures with chemicals. I would encourage you to pay attention to these measures in order to stay safe when using chemicals. The first one is read and understand the instructions written on the chemical container before using them. For example, this is a chemical container. Before using such chemicals, like the one I'm holding, ensure to read and understand the instructions that have been written on the container. If I look closely at this container, it says for use in car, home, and in the office. It also says shake properly before use. And another instruction says hold the can upright and spray it to the center of your room. So it says hold the can upright and spray it. If I don't follow this instruction, I might just spray it right into my eyes, and that could be dangerous. So always read and understand the instructions written on the containers before using chemicals. Also adhere to the manufacturer's safety instructions. That's keep to the safety instructions. Wear protective equipment such as gloves, as you can see, safety glasses, and respirator when using chemicals. There are other protective equipment you can also wear. It depends on the kind of chemicals you'll be working with. As you can see, this is someone working with chemicals. He's putting on gloves, glasses, and a nose mask, which is to help his respiration. This is in order to protect you from coming directly in contact with chemicals. Avoid touching your face and other body parts while using chemicals. Avoid that because you could just put these chemicals on your body parts. That could be dangerous. Wash your hands after using chemicals. Ensure to wash your hands to remove every bit of chemicals after using them. Always use the right amount of chemicals. Don't use too small and don't use too much. Follow the instructions. Use chemicals in a well-ventilated place. Let there be proper flow of air in order to avoid inhaling fumes of chemicals. So let there be free flow of air. After using chemicals, after mixing chemicals to be used, ensure to dispose of all unused mixed chemicals in the appropriate manner or as directed by the instructor. So when using chemicals in the laboratory, ensure to dispose all unused mixed chemicals in the approved manner. Chemicals should be left in the appropriate containers with the correct labels that identify them. You should keep them with the right labels and the right name in the appropriate containers. Don't put chemicals in salt container or sugar container so people don't mistakenly use them as salt or sugar. That would be very dangerous. Don't do that. Do not smell, taste, or touch chemicals in the laboratory except you are asked to do so. Don't do that. Lastly, you should store chemicals in a cool and safe place. Chemicals should be stored in a cool and safe place out of the reach of children in order to prevent them from going to cause harm to themselves with these chemicals. Now let's summarize all we've been learning today. So chemicals are substances that consist of matter and they can be gotten from or used in a reaction. Chemicals contain elements, and the smallest particles of elements are atoms. Chemicals can be grouped based on their acidic nature, uses, and their hazardous nature. Chemicals are grouped according to their acidic nature into acids and bases. Chemicals are also grouped based on the various uses into 6 groups: pharmaceutical chemicals, cosmetic chemicals, agro chemicals, industrial chemicals, laboratory chemicals, and nuclear chemicals. They are also grouped according to their hazardous nature into 3 groups. We have highly hazardous chemicals, moderately hazardous chemicals, and non-hazardous chemicals. Some of the safety measures taken when using chemicals are: keep to the manufacturer's instructions, follow the storage guidelines, and wear protective equipment when using chemicals. Okay, it's been an interesting class. I hope you've learned a lot. Well, to find out how well you've learned from the class, I'd like you to take these questions. 1. Cosmetic chemicals are used to manufacture the following products except A. Face powder, B. Water bottle, C. Body cream, and D. Washing soap. The correct answer is option B. Water bottles. Cosmetic chemicals are used to manufacture face powder, body cream, and washing soap. It is not used to manufacture water bottles. The second question is, which of these is an example of agrochemical? A. Quinine, B. Polycarbonates, C. Herbicides, and D. Ammonia. The correct answer is option C. Herbicide. Herbicide is an example of agrochemical. Thank you for staying in this class. We have come to the end of it. I hope you learned a lot. You can identify chemicals based on their uses, acidic nature, and hazardous nature. Hope to see you in our next class.